Okay, dear students, from this session we'll start a new chapter, that is stereochemistry. Okay, before we start, just we go through some good facts about the stereoisomers, right? So the living organism, their metabolic activities, natural synthesis, and drug synthesis incorporate various aspects of stereochemistry. So in this session, so that means that let us learn some facts about the stereoisomers of different compounds. They're well known. D-glucose is is metabolized by animal or human beings and fermented by yeast, unlike L-glucose. So that means two forms, D-glucose and L-glucose. Not small d, it is a capital D and capital L. Similarly, minus adrenaline, that is small L adrenaline, has more hormonal activity than plus adrenaline. That is a hormone, right? Similarly, minus nicotine is more poisonous than plus nicotine. That is, levonicotine is more poisonous than dextrose nicotine. The one stereoisomer of carbon has smell like the cumin, jeera, right? While the other isomer has a flavor of spearmint. One isomer of limonene has smell of lemon, while the other smell like oranges, right? And there are various different forms of benzene hexachloride, but only one isomeric form has insecticidal property, that is gamma BHC, that is gamma lindane. Okay, and all naturally occurring fatty acids have cis configurations. Okay, and similarly, one stereoisomer that is known as monosodium glutamate, that is MSG, is used as an active flavor, right? Enhancer, especially in our Chinese dish, that's a chow mein and the noodles, etc. Okay, so this also in this chapter we'll learn about these things. Okay, so in this chapter we'll learn regarding the introduction, configuration, isomerism. This is the syllabus, right? So the introduction, configuration, isomerism, optical activity, chirality, enantiomers, RS convention of configuration, designation, distereoisomers, and mesocompounds. Yeah. Now for this session, we'll start with the introduction, configuration, isomerism, plane polarized light, optical activity, polarimeter, and some numerical will do for this session. Okay, so the isomers which have same bond connectivity but different arrangement of groups or atoms in a space are termed as stereoisomers. Or simply we can say that the isomers which have same structural arrangement but the spatial orientation or the three-dimensional arrangement of various atoms or group are different, right? Like for example, if I take an example of butene, that is cis-butene and 2-trans-butene, right? They are stereoisomers. Okay, so the branch of chemistry which deals with the study of molecular structure in three-dimensional space is called stereochemistry, or simply we can say it's a branch of chemistry dealing with the study of three-dimensional nature of molecule is known as the stereochemistry. Okay, so we already learned some facts, right? So these that facts clearly indicate a difference in the three-dimensional arrangement of molecules may affect the properties of isomers drastically, right? So the various aspects of stereoisomers will be discussed in context of the following classification. One will come the configurational isomerism, that means molecule with chiral centers. So that will take later on. Then geometrical isomerism, that is a configuration isomerism due to the restricted rotation around double bond. And third one is a conformational isomerism, that is isomerism due to free rotation around a sigma bond. In short, we can say that stereoisomers are of two types. One is a conformational isomer and second one is a configuration isomerism. Right. So what is a conformational isomer? So in this, isomers go on changing into one form to another form very rapidly. Right. So why? Because of the rotation of sigma covalent bond and cannot be isolated. Like so, like the in case of the alkanes, staggered configuration, Gauss configurations, then both form the cyclohexane form, right? So these are the conformational isomers. Okay. Second one is a configuration isomerism. So in the configurational isomer, that isomers do not change into one another automatically, but they can get converted into another only if some bonds are broken and then re-established after rearrangement, right? Such isomers can be separated by some suitable method or means. Okay, so there are two type of configuration isomers. One is the geometrical isomers, which we already discussed in the previous chapters, right? In the geometrical isomers like cis, trans, or E or Z, right? And the optical isomers. Okay, Now the topic will come the plane polarized and optical activity. Ordinary light, just considered as an electromagnetic wave. So under ordinary condition, it will oscillate in all the direction perpendicular to the path of propagation. But under certain conditions, the light can be made to have all its oscillator in the same plane is called the plane polarized light, right? But the ordinary light can be turned into the plane polarized by passing it through some what we say some filters or through some prism, that is a Nicol prism. So basically, what is a Nicol prism? It is nothing, it's a crystalline form of calcium. So there are certain chemical substances such as camphor, turpentine oil, which rotate the plane of polarized light in a characteristic way when it is passed through their solution. So these compounds are called optically active. And the angle of rotation by which the plane polarized light is rotated can be measured by an instrument called polarimeter. Okay, and the optical activity of a substance is generally expressed in terms of specific rotation. Okay, so that is, specific rotation is nothing, it is observed rotation by length of tube in decimeter into concentration of solution, right? So when the substance which rotates the plane of light in the clockwise direction, that is are called dextrorotatory, that is represented by small d or plus sign, or substance which rotate plane or polarized light in the anti-clockwise direction, that is towards left, are called the levorotatory, that is L or minus. So this is the case of what we say the optical active substance, polarimeter, specific rotation. Thank you very much.